Alright, Chapter 24, Locomotive and Other rolling stock. Locomotive is a powerhouse mounted with a frame produced with the motive power needed with the traction on relay. The three distinct locomotives on the railways, each drawn with the power with different energy sources. Steam locomotive, motive power with a steam generator, pressure vessel called with the boiler, thermal energy, fuel converted with mechanical engineering motion, and diesel locomotive with motive power is an internal combustion engine using a high-speed diesel oil with a source of energy. Electrical locomotive derives its power from electrical conductor running from along the track. Type of traction. There are three types of traction on the Indian Railway: steam traction by steam locomotive, diesel traction by diesel locomotive, electrical traction by electrical locomotives. Diesel electric locomotives are comparatively more efficient than the steam locomotives. They have greater handling capacity, permit better acceleration, deceleration, capable of carrying heavier loads at high speeds. In view of the factors, the diesel and electric locomotives are fast replacing steam locomotives and can be seen in Table 21.1. It may be noted that, though that total holdings of locomotive of the Indian Railways have been decreasing since the last 25 years, average traction has increased progressively due to the provision of more efficient diesels as well as the electrical traction and steam place of steam traction. Nomenclature of steam locomotives. Steam locomotives normally identified arrangement of the wheels. This locomotive generally has two types of wheels. Driving wheel. The wheels are coupled with each other and directly connected with the pistons. The higher diameter of the driven wheels. Driving wheel, the greater the traction power, the lower the speed. Idle wheels, the wheel that distribute the load of the locomotive on the track. Locomotive normally designated with a three-digit code. The first digit indicates the normal idle window wheels of the front. Middle digit indicates the number of the driving wheels. And the last digit notes the idle wheels that come after the driving wheels. Locomotive nomenclature 462 indicates the four idle wheels for the front and 6 driving wheels. 2 wheels. Idle wheels are the driving wheels. It may be noted that the middle digit, including the driving of a couple of wheels, is most important. Hauling capacity of a locomotive is decided by the number of the driving wheels. 24.3 Classification of locomotive. The first locomotive hauled with the first India in 1853 with the Bombay, with the Bombay, and Mambi to Thane, imported with England, was named the Lord of the Falcon locomotive. The locomotive with the 240 type, since the more than 5,000 types of steam locomotives have been imported with the manufacturer with different gauges. Indian Railway standard classification various locomotives in the year 1929. Locomotives classified in 2 digits as in Table 24.2. W, X, and Y means broad gauge, A and L, A or L, light passenger, Y is meter gauge, B and B, me or P, standard gauge, Z is narrow gauge, C, heavy passenger, D and G, standard goods, E, heavy goods, M, mixed goods, and passengers, U, M, T, W, shuttling and shunting. In the case of diesel electrical locomotives, one additional alphabet D, A, and C is indicated with the diesel electrical engines respectively, thus Y and P indicates the steam locomotive of the meter gauge standard passenger train. WAG indicates the broad gauge of electrical motives used to haul the good trains. The Table 24.3 and unless the salient features some of the typical locomotives used in Indian Railways. Steam locomotive figure shows without the sketch of the typical steam locomotive there is part of the steam locomotive described in the following details. You have your cylinder, piston rod, bogie carrier, idle wheel, steam engine, boiler, connection rod, counterweights, coupling rod, driving couple of wheels, crank pin coupling rod, firebox, rear idle wheel, tender wheel. The boiler. A boiler consists of firebox, barrel, smoke box, coals, fire with the box, the wheel, where the water is converted into steam, the smoke with the gas from the firebox passes through the smoke pipe, finally get discharged through the chimney. The chemical energy in the fuel is converted into heat energy of steam. Your steam engine consists of a cylinder piston with the moving the parts that converts with the heat energy, the steam, and the rotary energy in the following manner. The steam head of the boiler first emitted with the cylinder fitted with the valve. The valve is operated with mechanically. Steam enters the cylinder in one side behind the steam piston and fitted with inside of the cylinder. The piston can move forward, backward. Steam exerts the force of several tons in piston. The force is transmitted with the crank pin fitted with the out of the center of each wheel, away from the center of the wheel through the rods. Other connections, linear motion of the pin is converted with the rotary motion of the wheel starting the rotating. The wheel and the frame. Locomotive is ideal with the wheel load, well as wheel load. The frame is supported on the wheels that carries the boiler and also holds the steam engine and other parts of the locomotive. The tender is provided with behind the locomotive to store fuel. The tender is the type of the mini wagon and supported with the wheels and coupled the main locomotives. General Indian Railways have phased out all steam locomotives. No steam locomotive is presently being manufactured by using on the railways. 24.3.2 Diesel locomotives. The diesel locomotive works with the principle for the diesel engine. Even the diesel fuel combustion takes place in the cylinder. The air inside with the cylinder compresses, raising the temperature of the air. The fuel is injected inside the cylinder, causing spontaneous combustion. The engine must compromise 4-stroke cycle with the causing section Suction, compression, injection. A suction, compressed ignition, exhaust. The engine can generate utilized with the driving of the locomotive. The horsepower generated with the diesel locomotive is transmitted into the wheels of the following manner: mechanical and transmission case for the conventional diesel locomotives, hydraulic transmission case for the diesel hydraulic locomotives, electrical transmission case for the diesel electrical locomotives. Diesel electrical motors have been quite popular, more economical operation, high effective efforts, even low speed. Although the steam mainline, broad gauge, and meter gauge locomotives of Indian Railways function via the electrical transmission, the different type of diesel locomotives used in the Indian Railways are as follows: broad gauge WBM1, WBM2, WBM3, meter gauge YDM1, YDM2, YDM3. Indian Railways have, however, the recently standard of the WBM2 diesel locomotive with the broad gauge YDM4 with the diesel locomotive with meter gauge, but the locomotive are all American Locomotive Company design, currently being manufactured by the DLW Varanies. The WMD2 locomotives are horsepower 2600, capable of hauling 36,000 tons. 3,600 tons of the train load at a speed of 72 miles an hour, 72 meters an hour. On the level track of the maximum speed of the achieved using the locomotive at 120 kilometers an hour. The very latest series of the motor of the WG2 locomotives for the good traffic WP1, WP2 locomotives of the passenger traffic. The locomotives have the greater horsepower series performance capabilities. Alright, 2433 electrical locomotives. An electrical locomotive movement is brought by the means of the electrical motor. The motor draws power with the overhead distribution system through the pantographs. Joined work frameworks conveying the current with electrical train from the overhead wires. The mount of the locomotive, they are different systems of feed with the power of the locomotive named 1500 volt DC, 700 volt DC, 25 kilovolt AC single phase through AC three phase. Most economical way of transmitting and distributing power with the directly transmitting of the AC power to industrial frequency, whereas the motors must be suited electrical traction or DC series motors. Indian Railway has locomotives that are both best both system locomotive. The DC series motors collect about 25 kilovolts in a single phase of industrial frequency of 50 cycle. The voltage is stepped down, and the lower voltage means the transformer presents inside the locomotive converted with 1500 volts or 700 volts. AC to DC means the silicone rectifiers and the power is then fed the DC series motors inside the electrical locomotive. The system has been adopted in India in 1957 and is based on the system adopted by the French National Railways. Alright, 1 is your headlight, 2 is the in-air filter air light, 3 is the starting fuse battery switch, 4 is the handrail, 5 is the cooling system air lamp, 6 is the radiator fan access, 7 is the coupler E and F type, 8 is the sandbox, 9 is the jacking pads, 10 is the wheels, 11 is the fuel tank, 12 is the compressed air system with the main reserves, 13 battery box, 14 truck, 3 axle with 2 motors, HGSC type quantity, 2 underframe, 15 dynamic braking grid, 16 dynamic braking fan, 17, 18 front mechanical part motor, 19 motor, 20 engine part, 21 trans part. Class WMP4 type AA1 gauge 1,676 millimeters surface passenger. Alright, your electric locomotive WAG 3. 1 driver's desk, 2 driver's seat, 3 pneumatic control compartment, 4 traction motor blower, 5 air compressor, 6 pneumatic equipment cubicle, 7 exhauster, 8 braking resistor set, 9 battery, 10 main transformer, 11 silicone rectifier block, 12 electrical equipment compartment, 13 braking sights transformer, 14 auxiliary electrical equipment compartment. Alright, earlier in Indian Railways had electrical traction system with worked up to 1500 volts of DC and 3000 volts AC. The electrification of locomotive in India was first taken under between 1925 and 1932 at 150 volt DC. Consisted of a 304 route kilometer of the Central Railways to Bombay, VT, and Ingapur or Pune in the 62 with the Western Railways between Churchgate and Vivar, 32 gate and kilometers with the Madras Beach and Tamaria. The section of 1500 volt DC was the power of the locomotive. Addition of 142 route kilometers for the Calcutta electrified using 3000 volt DC system in 1954 and 1958 through 1958, which subsequently became converted into 25 kilovolt AC system. The details of 4 different types of electrical motors used in Indian Railways are given in table 24.4. Broad gauge AC, WAM 1, 2, 3, 4, WAP 1, WAG 1, 2, 3, 4, 5, WCM 1, 2, 3, 4, WCG 1, broad gauge AC DC, WCG 2, WCM 1, meter gauge AC DC YAM 1. When WAM 1, WAG 1, WAG 3, WAG 4 locomotives are based on European design, therefore the WAM 1, WAM 4, WAP 1, WCM 1, WAG 5 locomotives have been designed in India with the six-wheel arrangement of the bogies, which is similar to the diesel of the WDM locomotives. Some of the locomotives are capable of hauling the last type of the box, and the end wagons air braking arrangement. It may be mentioned that the WAP 1 passenger locomotive has a vacuum as well as the air brake system designed to run at speeds of 130 kilometers an hour. The Rajahar Express of the Delhi Hurrah route is held by such a locomotive. The horsepower, weight, and maximum service speed is different from the type of locomotives in Table 24.5. Alright, 24.4, preventive maintenance for the locomotive. The efficient operation of railway depends on reliability and availability of the locomotive. The property by other efficient maintenance for the locomotive is based with economical train operation. Maintenance practices evolve with the basic principle and necessary attention should be paid to all assets before deterioration. Through the wear and the tear of the makes the prone failure of the known preventive maintenance. The preventive maintenance locomotive can be broadly classified into two heads, namely periodical overhead and scheduled repair. Steam and diesel locomotives. Prescribed life of the steam and diesel locomotives is 40 to 36 years, respectively. The view of the long lifespan imperative that both the assets and the properly periodically maintained ensure that there is no deterioration in the condition. Preventive maintenance in steam diesel locomotives is done in the following manner: periodic overhaul. Periodic overhaul, or POH, of the locomotives is undertaken in the railway repair shop. The frequency of periodic overhaul in steam diesel locomotives is for the follow diesel locomotive 6 years, or every 0.8 of a million 0.8 million kilometers of broad gauge, 0.6 million kilometers meter gauge. Steam locomotives passengers 0.3 to 0.35 million kilometers. Goods 0.2 to 0.25 million kilometers. Inferior service 5 years, or about 0.2 million kilometers. During the periodic overhaul, the locomotive is completely stripped and all the parts and components are required and replaced as the condition warrants. After the periodic overhaul, the locomotives are in almost new condition. Alright, scheduled shed maintenance. Various examination schedules have been drawn up as part of the preventive maintenance of the specific component of the part of the locomotives may be given an need-based attention interval. The examination schedule lists all the various aspects should be taken with the time of the maintenance, dependent on the wear and the tear of the component. The total number of the kilometers should have been covered, but these examination can be carried out. All of it has been specified. Steam locomotives. The table 24.6 outline the various types of schedules approved with the maintenance of steam locomotives based on the total distance of the kilometers covered by the locomotive. Schedule 1, type of schedule will cover 1 kilometers by the WPMG 16 YP and YG 950 to 11,000. Schedule 2 every month. Schedule 3 24,000 to 20,000. Schedule 4 48,000 to 40,000. Diesel locomotives trip the weekly scheduled fortnightly schedule, the monthly, the 3-month schedule, the 6-month schedule, yearly schedule, the 3-year schedule, the 6-year schedule have been drafted in diesel locomotives. The preventing maintenance schedules have been worked out with the basis of the experience and verdict of the investigation causing the lead of the breakdown locomotive. Compared to the steam locomotive, the diesel traction unit is far more complex, usually incorporating the indirect current control system, which is much more elaborate than ancillary equipment. As a result, with the greater complexity, it's more liable to render the unsurpassable value of the particular component. Therefore, in order to ensure the high standard of reliability, various schedules have been installed with the inspection, maintenance, the servicing of the minor schedule, trip of the fortnight, monthly, etc. Involved with the routine inspection, minor attention, and likelihood it takes about 4 to 12 hours. The major schedules take a longer time, lasting about 6 to 14 days, since they require repair and replacement of the major components. 24.4 to electrical locomotive. The schedule for the inspection check given in the table 24/7 generally filed with the Indian Railways to ensure proper maintenance of electrical locomotives. Weekly trip within 1,500 kilometers. Code trip 1 hour. Weekly trip inspection. 15 days fortnightly. 1 to 2 hours fortnightly inspection. Monthly IA code 2 hours incidental inspection. 2 months IB 8 hours complete partial inspection. 4 months IC 8 hours complete inspection. Every third IC AOH 16 hours annual inspection. At every 300,000 kilometers or after 3 years, the IDH 15 days general inspection. Intermediate overhauling after 600,000 kilometers or after 6 years, with periodic overhaul 30 days through the overhauling or periodic overhaul. or the frequency during the variation schedules have been defined with taking the several failure locomotive existing indigenous component for the atmospheric level, the heat of the dust in the country, and the consideration compared with the same diesel locomotives. Electrical locomotives include more contact or relays, auxiliary equipment, electrical quantity for the change of the condition of the locomotive are not physically visible. Therefore, it is essential to check the equipment contactor for the relay periodically assertion of the condition of the various equipment without making much of the dismantle. And most of the equipment gets inspected during the 4th month inspection. Those of these equipment are excluded for the annual inspection. During such inspection, the equipment are disconnected with mechanical fixtures. Fixtures examined with the strips and cleaned, and worn out damaged parts are replaced and reconnected. Trips and weekly, fortnightly inspections are conducted. Outstation running shed with all the other scheduled inspections of the periodic overhaul are carried out on the sheds. Periodic overhaul is carried out in the workshop. Alright, 21.5, rolling stock. Rolling stock includes locomotives, passenger coaches, good wagons, and all other types of coaches, wagons such as electrical, multiple units, diesel, railway cars, special wagons, or such as box wagons. Section given in some of the details of passenger coach and good wagons. Alright, 24.5.1 coach stocking. The different type of the passenger coach include the electrical multiple units that are part of the suburban train. Conventional coaches such as Class 2, Class 1, Class 2 sleepers, all AC3 Terrier to AC2 Terrier, one AC1 class coaches. 1994, the Indian Railways had stock of about 3,600 EMU coaches and 30,000 conventional coaches capable of carrying about a total of 3.7 million passengers. The passenger coaches have 3 basic structural design. Integral coach built with the Integral Coach Factory. Integral coach is built in Bangalore. Non-integral wooden body coaches are made in accordance with the Indian Railway standards design. Some of the salient features, 3 types of the coaches are given in Table 24D8. Silent features of the IRS, ICF, B, and MEL coaches. Type of the body, IRS wooden, ICF light metal, B light metal type. The structure wooden body resistant, grid steel underframe IRS. ICF all metal welded integral coach and tabular construction to BMEL, similar to the ICF coach, except for the areas load taken by the floor. Coach overall dimensions, IRS 325 millimeters width, 21,031 millimeters length, 3,886 height. Damage during collision and derailment, extensive damage. ICF 3,250 millimeters width, 21,337 millimeters length, 3,886 overall height. Less damage because of the presence of the anti-telescopic structure on the end of the walls that absorb shock. The BML 3,250 millimeters, 21,336 millimeters length, 3,926 height. Same as ICF. Alright, 24.5.2 good wagons. Good wagons are primarily meant for the carry good traffic. The Indian Railways presents the stock with about 0.29 million goods wagons hauling capacity of about 10 million tons. Good wagons most consistently covered and open with the wagons, special wagons such as box wagons carrying coal, other bulk traffic. Until the Middle East last century, the periodically all goods and traffic transport with general purpose wagons covered with on the high side, on open side, low side wagons. The standard wagon with the broad gauge of 4-wheelers within 21.19 tons haul capacity. The standard wagon was a meter gauge weight 5.69 tons, held the capacity of about 18.69 tons goods. Recently, a new bogie has been designed to pull the surface, which lay the emphasis on higher load, payload, provision facility loading, and unloading specific type of the traffic. This includes box, BCX, Bob X, Boy, Box XN, CRT, and wagons. This has been decided that the bogie wagons will be put in the service of railways, as all the 4-wheel wagons are not available on the unit with the president with the context bulk move with the combiners above the mentioned the classification wagon. B stands on the bogie wagon, C stands on the discharge, O stands for the open wagon, X stands for the high side with the center of the side discharge, Y stands for the low side of walls, N is used for air brakes, C is covered for the wagon, R is for the rail carrying wagon, T is for the transition coupler, and B indicates sometimes omitted all the new wagons of bogie stock. Alright, 24.6 brake system. Brake locomotives are applied with the stop of the move of the train. There are basically 2 types of the brakes. Compressed air brakes. The brake system is made with the brake cylinder compression containing the piston lever. The arrangement provided with under each of the vehicle. Brake piping running is provided with each of the rear vehicle, which extend with the main reserve of the locomotive. The reserve is provided with the part of the locomotive where the compressed air is fed into the air pump and with the compressed air is emitted with the system, the move of the piston with the application of the air brakes. 24/4 shows the compressed air brake system. Compressed air goes into the brake cylinder, the piston, then travels down the lever to the brakes. Vacuum brakes. The equipment consists of the vacuum brake cylinder, piston level arrangement provided by each of the vehicle. The cylinder is connected with the train pipe running from one end of the vehicle to the other. Direct emission valve with each of the closed with the view of applying the brakes in case of emergency. A vacuum brake about 20 inches of mercury maintaining the vacuum cylinder in one position side of the piston. To operate the brake system, vacuum exerts the effective working pressure on about 10 PSI pistons within the brake supply. With the vacuum cylinder is designed to supply with the required amount of the brake piston, brake power to the wheels maximum using the vacuum. Or this shows the 24/5 shows the vacuum braking system, tailpipe going down in the direct administration valve going into the brake cylinder piston, moving the levers in the vacuum brake system. Alright, vacuum brakes versus air brakes. It becomes necessary to run along heavier and faster trains on account of the constant increase of the traffic of the railways. Therefore, whether the prevalent automatic vacuum braking system is continued with has been improved. The feasibility of the air brake system is explored. Fundamental consideration governing performance of the railway braking system summarized here. The fast propagation of the air along with the entire train length to ensure the uniform application of the brakes. Very rapid type. The initial type filing of the cylinder brake blocks quickly brought into contact with the wheel. Throughout the process of deceleration. See a slower subsequent filling of the cylinders to allow the gradual retardation of the wagon. A fast release brake through the train length of all the train can restart quickly and having come to the stop. Their air brake system claimed the superiority over existing vacuum brake systems in the other spheres. However, the air brake system has a few comparative disadvantages as follows. Long trains give sluggish response to control of the driver. This time, the required for the compressed air to reach the last vehicle is considerable. If some of the reason of the train gets divided into two parts, the front portion of the train gets received the power to operate the air brakes, whereas the rear portion does not receive it. This can result in the accident. Alright, 24/7 maintenance of the coach and wagon. The prescribed economical lifespan of the coach and wagons is 30 to 40 years, respectively. Coach and wagons go through periodically maintenance in order to ensure with a good working of the order thoroughly lifespan. As stated earlier, the basic principle to follow under the preventive maintenance system is that the equipment should be paid the necessary attention so that there is no wear, tear, and consequently deterioration. Wagons do not make prone to failure. Some of the other principles followed under the scheme of the plan maintenance are outlined here. The implementation of the scheme should be as simply as possible to involve the minimum maintenance amount of paperwork. The maintenance schedule prepared every time that requires planned preventive maintenance. When scheduled is executed, a brief description of the action taken with the type of the labor employed, the type of time taken to be noted. Preventive maintenance applied with the coaches, wagons, and railways is classified under the following: periodic overhauling in the workshop, scheduled maintenance, schedule and breakdown maintenance, carriage and wagon depots on sick machine lines, running repairs on terminal yards. 24/7 periodic overhauling in the workshop. Coaching stocks are provided to overhaul the workshop in prescribed intervals based on the type of service which the frequency of periodic overhaul varies from 12 to 24 months. Such an overhaul consists of lifting involved with a thorough examination of all the components and execution, such as repairs not being necessary to ensure able the vehicle to remain in service. The next periodic overhaul, the prescribed interval with the periodic overhauling goods stock presented to 24/9. Periodic overhaul goods, blocks, and wagons, 4.5 to 4 years. Brake wagons, 4 years to 1 year. Intervals, container 1.5 interval a year, post 1.5 year, 1 department stock 4 and 4. Other wagons 4 and 3.5. 472 scheduled maintenance. The main different type of the rolling stock of the approved the schedule to describe below coaching stock. Between the consecutive overhauls of the coach of the service with the coaching depot of the basic schedule name known intermediate filling with them normal done within 6 months of the day of the period overhaul the periodic overhaul lifting during the process lifting trolleys underframe members body with the floor of the coaches add thoroughly examine necessary repairs and replacement component with the running of the gears are carried outside buried century pivot oil with the replenished similarly the coaching stock fitted with the plain bearing axle box distinguished with the rolling bearing axle undergoing the process of the repacking generally periodic as followed mail express trains coaches 2 months passenger trains coaches 3 to 4 months or other coaches 4 to 6 months. Good stock. All axle box will with bearings are entitled to the good stock periodically repacked with maintenance at depots according to the prescribed schedule. In addition to the axle box packed with the wagon lifted off the wheels, roller bearing axle boxes attended to the workshop during the overall maintenance. Alright, coaching and good stock. The few scheduled to come into both coaching and good stock from some of the important maintenance work that's done with the complying for these schedules over the volume. Vacuum brake cylinder. The vacuum brake fitted for the stock must be overhauled in intervals of 18 months in the case of the coaching stock, 18 to 24 months for the case of good stock. Normally there's separating section vacuum cylinder overhauling maintenance depot. Axle boxes. Axle box plain bearings. The coaching and good stock are oiled periodically. The coaching stock of the oil on the passenger is oiled every 15 days. Good stock permanently surface faceplates must be lubricated within 225 grams of oil per axle intervals with 1 month either maintenance departments of the original temperature yard. There are many other scheduled maintenance working as such as alarm chain, apparatus tank, testing tank, wagon valve testing, water tank painting, and which etc., which are implemented in the maintenance depot at prescribed frequencies. Alright, 2473 breakdown maintenance. Maintenance depot intended with all the breakdown failure for the rolling of the stock. Breakdowns are unusual incidents resulting in either human failure or due to the failure of the equipment. Some of these breakdowns are even a result of accidents. The most common failure of the coach wagon in which one occurs as the result of the axle box heating over the course of run, popularly known as the hot box. Every journal, the part of the axle extended with the bearing the weight of the wheels become hot during the running with the train, thereby necessitating detaching the coach and wagon the train before it can be booked in destination considering hot box. There are many other kinds of breakdowns which must be attended to in a maintenance depot to ensure the safety of the wagon. Cracked wheel tire, expanded axle guard, bent sole bar, dead buffer, leaking water tank, wheel defects, etc. 2474 with running maintenance of the terminal yards. Rolling stock they move most of the time, but the major schedule of maintenance of the overhaul and only one due with the call for the temporary mobilization stock with the normal maintenance of the stock due to the course of the service of the terminal yards. Maintenance mainly involved the examination inspection with the coach and wagon. The trains are carried out in 2 stages. Stage 1, an approach to the terminal yard where the train is still in motion. Stage 2, the terminal yard where the train normally stops. The first stage of the inspection helped discovering those defects under gear with indicating the unusual sounds of the disjoint of the broken hanging components. For example, the flat tire indicated the heavy thundering of the train and passing over the rail. For the second site, each of the coach thoroughly examined all the defects, both exterior and interior of the recorded rectification. Coaches or wagons found the defects that can be attended only in maintenance depots or marked with the handling over the remain coaches. The wagons are intended to terminal wash lines on the yard itself. 24.8 designing feature of the modern coach on the good side. The introduction of high-speed train of the Indian Railways has necessarily come with the change with the design of the rolling stock. Important design and feature during the modern coach of the good wagons are described in the following sections. The need for the increased number of the passenger is in everyday coach along with the provide with the good comfort that include introducing and having more coaches in every train running terrains with the progressively increasing speed necessity modernization rolling stock. The coaches manufactured by the Integral Coach Factory China are latest design modern coach may be lightweight made of metal and have the tubular structure, the trough, the underfloor, the side of the roof, the welded together to form an integral unit of the floor. Consist of the crossbeam specially designed head stocks and sole bars, etc., all of which are welded together, sealed through the flooring, run with under the crossbeams welded to the headstock and the sole bars. Advantage of through the trough section withstand the greater longitudinal loads, that still help in keeping the check of the weight of the coach. The curved body of the coach resides with wind resistance helps stability, and also accessible to design absorb heavy impact shocks. Further, the end of the underflooring of the design collapsible, though the case of the accident is absorbed the maximum force of the impact. Tubular structure ensure that the catch does not collapse inward. They ensure the maximum passenger safety against heavy impacts. The ICF coaches are then called anti-telescopic coaches. Like the coach body, but the rest of the ICF bogies is also a welded lightweight design of 9 foot 6 inches rigid wheelbase running on the roller bearings mounted on the pendulum type of the axle box. The axle box guide with the fitted with the dash pods for the absorbing effect of lateral bumps. Low shocks absorb the front and absorb the lateral shock. The fitting of the cold springs design the bogies to ensure that they provide very smooth slide. Alright, 2482, good stock. The Beat box type of the open wagon, the most significant of all the new wagons. It has a tare weight of the 25 tons, the hauling capacity of the 55 tons. It has a robust structure fitted with the center of the buffer couplers at the end with the provided with the automatic coupling that runs 2 bogies fitted with the roller bailing axle. The wagons are more suited for the long black rakes, consisting of between 35 to 45 box wagons per train, carrying bulk committee with the high speed. The coverings version of the type of the wagon, the BCX wagon measures 14 13.5 meters length and 3 millimeters in width, about 2.5 meters in height, and from the inside with a hauling capacity of 52 to 78 tons. It was a two-wing cum-flap doors on each side of the provided with a center floor buffer couplers. The effort behind the design of the wagons have been directed towards the increasing of their size. Average overhaul haulage capacity of the wagon provided with increased bid to observe the growth traffic as possible without increasing the line capacity with the costly terms of both money and time. There are three types of traction motors in Indian railways, namely steam traction, diesel traction, and electrical traction. Steam traction gradually have been replaced with diesel electrical traction. Electric traction has been advantage for the diesel and steam traction is possible, most suitable for the high-speed and super high-speed tracks. Locomotive, coach, and wagons are three components of the rolling stock. Rolling stock is the modern track of the Indian railways, which is designed to manufacture an integral coach factory. Shania. Special attention is paid with the maintenance of these coaches, which have been modified to suit the growing of the needs for the railway. Chapter 25, Train Resistance and Tractive Power.